90-degree angle. All right, so there's a 30, 60, 90. So these are the angles. And the sides of a 30, 60, 90 and the angles have the same relationship, right? They have a relationship that never changes. If there's a 30-degree angle in a right triangle, you can always find the side measures. Okay, so if you know 3 things about a triangle and one of those things is a side, then you can find all of the other things. So what I'm going to do is, here's my 30-degree angle here. Opposite that 30-degree angle is the shortest leg. So we're going to call this the short leg. And it has a measure of x. So, and the relationship between the 30-degree angle and its corresponding side will be the opposite side of the angle, right? So we're going to call that side measure x, okay? Then you have the hypotenuse, and I'm going to talk about that. The hypotenuse is obviously opposite the right angle. It's the longest side of the triangle, and it has a measure. If this is a 30, 60, 90 right triangle, then the hypotenuse will always be double the length of the short leg. So that is the relationship on a 30, 60, 90. They're really easy to identify because the shortest leg will always be half the length of the hypotenuse, always, or the hypotenuse will be double the length of the short leg. Then you have the long leg, which is opposite the 60-degree angle here. So this is the long leg, and the long leg has a relationship to the short leg as well. It has a measure of the short leg times the square root of 3. Always has that measure. And so on the 30, 60, 90, the opposite of 30 will be measure x, the opposite of 90 will be double x, and the opposite of 60 degrees will be x times the square root of 3. So for example, if you have the short leg is 10, then the long leg, or the hypotenuse, would be 20 units, and the long leg would be 10 times the square root of 3. Or say you had, for example, the hypotenuse was 4, right? So if the hypotenuse is 4, then the short leg would be half of that. That would be a measure of 2. And then the long leg would be the short leg times the square root of 3. So 2 square roots of 3. So that's how that relationship always works. It doesn't matter the size of the triangle, whether it's a big triangle or a small triangle. It's all about the relationship between the 30, 60, 90 and the ratio of the measures of the sides. It's always x squared root of 3, 2x. Okay, so there's the 30, 60, 90. The other one's easier. This is the 45, 45, 90, right? This is the isosceles right triangle. So I'm going to try to draw one here. That did not do very good, but there we go. All right, and so this is what we would consider a 45, 45, 90 right triangle. And that is enough, what I just drew right there, to indicate that this is a isosceles right triangle. These little tick marks here that I drew are indicating that the 2 legs are the same length, right? So I'll just do those in blue. This is a leg and this is a leg, and this will be 45 degrees, which forces this measure up here to be 45 degrees. If 2 angles are the same on a triangle, then 2 opposite sides will be the same as well. All right, they're going to have a measure of x, some unknown measure. They will be the same measure. Now, there is a relationship between those 2 legs and the hypotenuse. The hypotenuse will be the length of x times the square root of 2 all of the time. You could prove this to yourself by using the Pythagorean theorem, where you could do x squared plus x squared equals hypotenuse squared, right? So that's 2x squared equals hypotenuse squared, divide by 2, x squared equals the hypotenuse squared divided by 2, take the square root. Actually, you're finding the hypotenuse, so I should go the other way, but anyways, you could do that to figure that out, and I'm just going to erase that. But trust me, that's the relationship. So for example, if I say that the side of a 45, 45, 90, one of the legs was 5, then the other one's 5, and the hypotenuse would be 5 times the square root of 2. You could do that. All right, so it doesn't matter the size of the triangle, whether it's large or small. It's all about the angles. If it's a 45, 45, 90, then the 2 legs will always be the same measure, and the hypotenuse will always be that measure times the square root of 2. if it's a 45, 45, 90. Okay, so those are reminders. I will tell you that often when I'm dealing with one of the measures, a 30-degree angle or a 60-degree angle, I will write down the information that I just kind of encircled there. I will just write down the 30, 60, 90, the x squared root of 3, 2x, and I will draw a depiction of it. And I do the same thing if I'm dealing with a 45-degree angle. I will write 45, 45, 90, x squared root of 2, and I will draw a depiction. Okay, so since those relationships are always the same, you can always use them to help you solve problems that involve a 30, 60, 90 or a 45, 45, 90. Again, they're my starting point. So the instructions say find the measure of the sides of the special right triangles if the hypotenuse is 1. If the hypotenuse is 1. So remember what I just said. I always just write this information down. 30, 60, 90, x squared root of 3, 2x. Just practice it, and then I'll draw a picture. So there we go. 30, 60, 90, x squared root of 3, 2x. Done. I've got it. You see that didn't take me very long. Practice it. Do it. Okay, so here's what we know. We are asked to find the measure of the sides if the hypotenuse is 1. So here's what I know. The hypotenuse, which is represented the opposite of 90 degrees, or double the short leg, is equal to 1. So all I need to know now is if I know what x is, I know what the other two measures are. So I'm just going to use algebra here. If 2x is equal to 1, because the hypotenuse is double the short leg, we can divide by 2. And so that means that the short leg has a measure of 1/2. All right, so there's that measure, and all we have to do to find the measure of this long leg is to plug in 1/2 times the square root of 3. That would be your long leg, right? And so that would be the square root of 3 over 2, which is approximately 0.866 something, but we like the exact value there. So that's the square root of 3 over 2. And so our measures are 1/2 square root of 3 over 2, 1 for your 30, 60, 90. All right, so there you go. That's how you would use that information that we just went over and the hypotenuse measure to find the other measures. Let's do the same thing for the 45, 45, 90. So on the 45, 45, 90, we have the measures x square root of 2. That's the relationship of the sides. And in this case, we know that the hypotenuse is 1. All right, so I'm going to just quickly draw a right triangle here that's about a 45, 45, 90. We'll give it a go. We're going to just call it what it is. We're going to call it what I said it was. So this is x square root of 2, and I don't know why I did those in blue. I meant to do them in black. So I'm just going to change them real quick. Probably could have just rewritten it faster than I did that, but that's okay. All right, so I want to find the measures of the sides. Here's what I know. The hypotenuse is 1. And I just need to know what is x. So if the hypotenuse is x times the square root of 2 and it's equal to 1, what I want to do is use my algebra to isolate x. So what is the measure of that side? So what I would have to do if I'm working from the hypotenuse to a measure of a side is I would have to divide by the square root of 2 to isolate x. So x would be equal to, or the measure of this side would be 1 divided by the square root of 2. And you could plug that into your calculator or whatever. But that would be the measure. However, I will caution you that I am a teacher that does not like to see radicals in my square root. In my denominator. Because it's very difficult to divide by an irrational number. I don't know how to do them. So what I will ask you to do often, and you will get good at it, is I will ask you to rationalize the denominator. Take the square root of 2, which is irrational, and convert it to 2. Make it a rational number. To do that, you're going to multiply by 1. You're going to just change this fraction. You're rewriting it. It's kind of like taking 3/4 and rewriting it to 6/8. You just multiply the top and the bottom by 2. We're just rewriting the fraction so that the denominator is rational. So I'm just going to multiply the fraction 1 over the square root of 2 times the square root of 2 over the square root of 2, which is 1. And anytime you multiply times 1, it's still 1. But that moves the radical to the numerator. And the square root of 2 times the square root of 2 is the square root of 4, which is 2. And so the measures of these sides would be the square root of 2 over 2 and the square root of 2 over 2. Now, here's the thing. That may be the first time you've seen those relationships with a hypotenuse of 1, but it is certainly not going to be the last time you see it. You will see it again today and then over and over and over again for like the next 15 weeks. So the faster you can memorize this information and have it readily available in your brain for access, the better off you are. Okay, so what we're going to be doing now is constructing a 30, 60, 90 degree triangle and a 45, 45, 90, like perfect constructions without using a protractor. So we're not going to use a protractor to get a measure of 30 or 60. We're going to use a compass and a straight edge. All right, so we'll start with the 30, 60, 90. And what we're going to start with is we're going to construct an equilateral triangle, a 60, 60, 90. I'm sorry, try again, 60, 60, 60 triangle. And then what we're going to do is cut that triangle in half and create two 30, 60, 90s. All right, so what I'd like you to do is let's just put point A. Let's make segment A, segment B, and you can do that on both of those. And what we're going to do is we are going to use our compass in two manners. It's going to be a measuring tool, and then it's also going to make all of our little marks with our measures. So what you're going to do is you're going to take your compass. Let me rotate it around here so it's in the screen so you all can see it. And you're going to take your compass and you're going to put your stylus on point A, and you're going to open your compass to point B. Let me rotate it up here. And be precise. We want to get the measure of AB, because what we're going to do, possibly, is we are going to create a triangle where point C is up here and side AC, side BC, and side AB are all the same. It's equilateral, right? So I get that measure. You get that measure. And then what you're going to do is you're going to swing out, and you want to be above the halfway point here, because if we get it exactly at the halfway point, we can create a 60-degree angle. So we're going to make an arc up here, and we're going to also swing down. I'm going to have to move my screen down a little bit. There we go. And make an arc down here. Oops. Okay. And then we're going to do the same thing so that's the measure from A to somewhere out here, point C, but we need an intersecting point. We want these two measures to intersect. So I'm just going to double check that my compass is still the right measure. There it is. And I'm going to swing it out. Let me just scroll down here a little bit, swing it out. I just want to intersect that arc there, and then we'll swing it up and we'll intersect that arc there. Okay, so now I'm going to move my compass out of the way, grab my ruler. All right, and then I'm going to just pick up my pen here, and up here at the intersection of those two arcs is going to be point C. So now I'm just going to use my ruler to connect A to C. That will be the distance, the same distance from A to B as A to C, and then I'm also going to connect B to C, and I'm going to create a perfect equilateral triangle. So I'm just going to rotate this. Let me see if I can get it rotated here. Here we go. Rotate that up, line up those points, and then sometimes this is hard to do. Gonna line that up. Okay, and so there I have side AC, and then I think I'm going to rotate it again. So let me get this rotated around here. Put that point there. Rotate that around, line that up. And what we've just created here That's not going to work. Let me try that again. All right. What we've just created is a perfect equilateral triangle. So that's 60 degrees, that's 60 degrees, and that's 60 degrees. Well, what we want is a 30, 60, 90. That is 60, 60, 60. So we need to drop that 90-degree angle in there. Well, what we did was when we did those intersecting arc measures on the top and the bottom of segment AB, is we created what's called the perpendicular bisector. If I were to take this intersection of these two arcs and this one up here, and I were to line those up with using my ruler, let me rotate it around, send my ruler out here, and I were to draw a line between them, like so, what I would do is take segment AB and cut it in half and create what we call the perpendicular, that's the right angle, bisector. Cut it, intersect it, bisect it, cut it in half, which forces this angle up here to be cut in half as well. Remember that triangles add up to 180 degrees. So if this is a right angle 90 degrees created by your perpendicular bisector, and this is 60 degrees because it didn't change, then this up here, this 60-degree angle, had to be cut in half. So what we did is created actually two 30, 60, 90 right triangles. Okay, so that's how you do a 30, 60, 90. And we're going to start the 45, 45, 90 in the same manner. First thing you're going to do is take your compass and use it to measure the distance between A and B, like so, and create those arcs again so that you can get that perpendicular bisector, so you can create that 45-degree angle. You guys should see me. I'm acting like I'm on, you can see what me, like if I'm on a Google Meet. You guys can't see what I'm doing. I'm over here gesturing. I'm such a dork. Anyway, so you get that measure from A to B and you swing it out, make an arc halfway above the midpoint of AB and halfway or at the midpoint between AB below. Then you're going to just move your stylus or your tip of your compass to the other side, swing it around. You get that same measure. So again, it looks like we're creating that same triangle, right? And we are, but we're going to do something different. So instead, 45, 45, 90s, recall that the two legs of the right triangle are the same length, right? And so what we're going to do first in this case is create the perpendicular bisector. So I'm just going to draw that in there like so. All right, awesome. So now I have the right angle and I'm going to make this point D right here. So if I want this to be a 45, 45, then what I want is for the length AD horizontally to match the length to DC vertically. So I'm not going to use my ruler to measure that. I'm going to just use my compass, which is a better tool for accuracy. I'm going to measure the distance from A to D and get that measure, which is right there. So there's my measure, right? There it is. And so what I'm going to do now is just move the stylus to point D, maybe, there we go, and rotate that up vertically. And that's still the same measure between A and D. And then we'll put point C up here. So that's going to be the intersection between our perpendicular bisector and the segment AD. I lost my train of thought. So if that didn't make sense, I apologize. I totally lost my train of thought. And then you're just going to connect. Let me see if I can rotate here. From A, let me rotate it so that it's actually hitting point C right there. because we want those measures to be the same. And we're going to draw in our hypotenuse. And there we have created a perfect 45, 45, 90. Again, using the perpendicular bisector to get that right angle in there, and then using the measure between A and D in your compass, that vertical or that horizontal measure, to get your vertical measure from D to C. And there you go. Okay. So now on to the pre-calculus portion of this lesson. Okay, so you will be asked to draw angles in standard position throughout all of pre-calculus. And so let's start talking about what is standard position. Standard means it's the same. It doesn't matter what class you are in from now on. If you're asked to draw an angle in standard position, you have to draw it thusly. So we're going to start with the vertex of an angle, because remember, angles have a vertex and then they have two sides, two rays, right? So let's start with the vertex. Where is it located? The vertex is located at the origin. So we're going to put it on a coordinate plane. Let me just zoom in here a little bit. We're going to put it right here. So there is the vertex, okay? Now, to make the angle, of course, we have to have the two sides. So I'm going to switch to blue, and I'm going to talk about the initial side. So this is some vocabulary here. The initial side of a coordinate plane is fixed. What does that mean? That means it doesn't move. You plot it, and it's always the first side that you plot, and you always plot it in the same place. It is fixed on the positive x-axis, and it doesn't move. So it's right here. Hang on a second. Let me see if this will draw me a line like it usually does. This is your initial side. Initial, meaning you start here, okay? And this is actually the measure without any rotation of 0 degrees or 0 radians if we were talking about radians. Okay, so that's the initial side. So that's just a ray. In order for make an angle, we need another ray. And so I'm going to switch to green, and I'm going to talk about the terminal side. So the terminal side is the side where the angle stops. So the terminal side rotates to theta, which is the measure of the angles. Now, theta is just the Greek letter because the Greeks came up with trig. So we use Greek letters often to indicate the measure of an angle, right? So let me just draw a terminal side here. And this is 0 degrees. And what this terminal side does is this is the side that moves. So if we're going to go to 120 degrees, well, we'd bring it over here and we draw something like that, right? Because this is 0 degrees. And when you rotate up, let me just see if I can grab this. When you rotate up, you're rotating in a positive way. If you rotate down, you're rotating in a negative way. So if you rotate up from 0 degrees, you're rotating in a positive manner. Okay, so I'm just going to go ahead and put that measure right there. Sorry about that. And I'm going to call this the terminal side. This is the terminal side of the angle. And what we get with the terminal side is the measure from here to here, which be angle theta, or if we don't know the angle's measure, a lot of times we'll label it as angle theta or angle alpha or something like that. But that is the standard position of the angle, and then if we know the angle's measure, we can draw how large or small it is. Okay, so that is the standard position all the time. And this right here is what we call, well, no, actually, if it's acute, we would call it the reference angle. This is the reference angle, but so don't pay attention to that. Okay, there it is. That is the standard position. So now what I have done here, and if you didn't print out the note page, but you have a compass, right? You have a compass and you have graph paper. Then what you can do is, I gotta fix that because there's a little issue here. Let me fix that. You can just draw an XY coordinate plane in quadrant 1, just like I have here, and then just count out 10 units, or you could count out 6 units or 8 units, any number that's easy to cut in half, and label that from here to here, 0 to 1, and do the same thing, 0 to 1. like that. And then get your compass and put the compass stylus right here, measure out whatever your 1 unit, Eudanus 1 unit, and draw a quarter circle. Okay, this is useful because you are asked to draw a right triangle in standard position on the coordinate plane with a hypotenuse of 1 unit. So what I've done is if I draw a circle, and this is the center of my circle, and then this line right here is my radius, right? It's always going to have a radius of what? It's a circle, so the radius is unchanging. So it's always 1. And so this is the purpose of that curve right there. Okay, hopefully I've given you enough time to draw that. All right, so we want 30 degrees to be our reference angle. So this is what we're going to do is draw a 30, 60, 90. With 30 degrees has to come off the origin because remember in standard position, the vertex has to be at the origin. So we want 30 degrees right here. That's what we want. Okay, so remember on a 30, 60, 90, we did this before, right? If we have a hypotenuse of 1, right, then the vertical measure is 1/2 because there's 30 degrees right there, and the horizontal measure is that ugly square root of 3 over 2. So what we want is this vertical measure to be 1/2 and the hypotenuse to be 1. So this would be the square root of 3 over 2, which is approximately, again, 0.866, but so that's like right here somewhere, but I don't know exactly where it is. But vertically, 1/2, I can find that measure. It's right here. This is vertically up 1/2. So if I just come out here to vertically up 1/2, right? That's a distance of 1/2. Then I can connect the vertex to the end of that circle there, and that would be my radius of 1. And if this is 1/2, remember that we talked about this. If x is 1/2, the short leg is 1/2, and the hypotenuse is 1, this has to be a 30, 60, 90, and 30 would be the opposite of the length that's 1/2. Okay, so there's a 30, 60, 90 right triangle in standard position, where 30 degrees is the angle that we're referring to, we're referencing. Okay, so let's do the 60-degree reference angle. So now I'm just going to reorient this, right? Because it's still a 30, 60, 90, but now my focus or my reference is going to be the 60-degree angle. So I want to be able to, go from 0 degrees here up to 60 degrees. So where would I stop that line? I'm just going to leave it right there. So reorient it. So here's your x-axis, right? And so there's your vertex. So if your 60-degree angle is down here at the base, then your 30-degree angle is up there. This still has a horizontal or a radius or a hypotenuse of 1. So the horizontal measure is 1/2, and then the vertical measure is the square root of 3 over 2, which again is 0.866. Okay, so that's somewhere up here. But 1/2 horizontally is easy to find, so I can just go up to the edge of the circle right there. The circle is not drawn perfectly here, so let me fix it up. That's terrible. It must not be an exact circle. Let me draw a circle real quick. Try again. Okay, there we go. And I just have to get that lined up. And scooched over. Apologize. Almost. Close enough. All right. So I'm just going to get rid of this extra part here and here. All right. So it's close enough. Anyway. Hopefully your picture is better than mine. All right, so up 1/2, which would be about right there, which is about 0.866. And then use your ruler to draw that there. Drop in your right angle. There it is. And there is your 60-degree reference angle right? Okay, so something else I want to mention before we do the really easy one. The last one's really easy. I want to talk about these coordinates. So horizontally, this is at the square root of 3 over 2. That's this measure right here. And vertically, you're at 1/2, right? Whereas on the 60-degree reference angle, which is this picture here, those two coordinates reflect. Not reflect. They're inverses. The x's and y's switch. So that's interesting that a 30-degree angle is the inverse of the 60-degree angle. That's interesting. But anyway, there you go. Remember how I told you these numbers would be important? They are. Okay, the last one is the 45, 45, 90. With a, so that's our reference angle, and then we want our hypotenuse to be 1, so again we have that circle there. Well, 45, 45, 90, if you recall, looks like that, where these two are the same measure. So if that's 1, the hypotenuse is 1, then the sides are the square root of 2 over 2, which is approximately 0.7071 or 0.71, which is like right here, right? And right here, baby. Right? But simpler is to just take this 90-degree angle right here and cut it in from tip to tip, from diagonally, and that will create a 45-degree angle, which, if you see here, gives you this measure of the square root of 2 over 2 and the square root of 2 over 2. And there you go. And that's how you do that. So our coordinates, the square root of 2 over 2, the square root of 2 over 2, and the radius or the hypotenuse is 1. And that's it. Have that ready because that's your homework. You got to upload the completed page with all of your extra little notes.